So there were some spoilers here, but okay. So as you've heard, I'm Paweł, and I'm gonna tell you about oracles. Maybe, oh, there it is. Yes, I'm gonna tell you about oracles. So the first question you might have, what are oracles? So this, no, not about this today. And also, some of you may know this movie, and this is the Oracle from Matrix, but also not this. It's not going to be the topic of our discussion. This is a representation of mythical oracles, which is almost the thing we're going to talk about, but not exactly. And blockchain oracles are exactly what we are going to talk about. So both mythical oracles and blockchain oracles know the truth. That's the idea behind oracles. They tell it to anyone who asks, and sometimes require sacrifice in the case of mythical oracles, and some payment maybe in case of blockchain oracles. But first, let's talk about the oracle problem. What is it, and why do we actually need oracles? So we know that blockchains are very nice and we love them because we are working with them every day. They are immutable and secure. So no one can change the data, and we always know that once verified, the data is stored and secure, but they are also isolated. The problem with isolation is that we cannot, the blockchains, but by themselves, don't have any ability to contact the outside world. And we have a lot of data outside of blockchains. And we want this data inside blockchains so we can operate on them and write, for example, smart contracts that do something with it. So anyone claiming that they have solved the Oracle problem is full of assumptions, let's say. Because, for example, who are we going to allow to update the Oracle? Let's say we have a smart contract on the blockchain side, and we allow someone with a specific key to update the values of the Oracle, for example, price data. Let's say the price of ETH or price of something else, pen, pineapple, apple, or something else. So the problem with having only one person update this Oracle is trust. We don't want to trust only one person. That's why we built blockchains in the first place. Then we can have multiple feeds, multiple people that are updating the Oracle contract but here there's also a problem. How do we know which update to take, and how do we know if someone is actually not genuine with this, with their information? That's why we need some kind of conflict resolution. So to resolve these conflicts, we implement some kind of consensus mechanism. For example, with prices, it is very common and usually projects implement a median. They take the values from multiple feeds. They then calculate the median value, and that is stored on chain as the actual price for this period of time. But this actually, at least with the current gas prices, is very expensive, because having this median calculation done separately for each feed means we have multiple transactions that need to be verified, and then this costs a lot. So what we could do is actually introduce a third-party relay that gathers all the information from the feeds that post data about prices or anything else, actually. And we let only one entity post data on the blockchain. But this on the other hand, introduces us to a different problem, which might be censoring. So the single relay that we implement can be censoring other feeds. So we need something more sophisticated, let's say. So we try to decentralize the relays also. So we have multiple feeds on one side and multiple relays on the other side. And each of this relay has all the data that other feeds have provided. And at least one honest relay is enough to make sure that we post the data to the blockchain and no one is censored. Because, and of course, projects need to incentivize positive behavior and maybe use some kind of slashing or something if someone posts not proper data. So first we have the off-chain side, which is quite important. And for example, we can have a feed that communicates through a peer-to-peer network with relays. With this is a signed price message, an example from a signed price messages in the Maker oracles. As you can see, we have the type specified, we have the version of the software used, we have the price, and then we have some hex data, and we have a hash, and the signature of the feed that has actually created this message. And I will not be going into the detail of the off-chain side today because there's a lot of it. And if you would like to see the software that is actually doing it for Maker protocol, you can go to these addresses. So first, Oracles v2 is the second iteration of oracles that were implemented by Maker. And it's an orchestration tool, let's say, that utilizes other projects, other software to create the whole Oracle system. So we've got Omnia, which is the software for feeds and relays, and we've got the Oracle Suite, which is a re-implementation of this software in Go, and also it has a very modular structure, so any project could actually be using some parts of Oracle Suite to use for their advantage. And on the chain side, so we have smart contracts that need to realize a few functions. So we need to make sure that only some trustworthy feeds are posting data to the chain. So smart contracts needs to have some kind of authorization. Then we have the consensus protocol. Of course, in the case of prices or other numeric values, it's usually common and makes a lot of sense to use a median of the values, because any outliers, any values that go way beyond what we would consider correct value will actually be filtered out by this kind of consensus. But we could actually implement something else. We could implement, let's say, a majority vote for some values that are not so easily quantifiable. So feeds could actually attest to something that happened, a fact, from any domain, actually. And then the consensus method would be to have a majority vote from the feeds and to choose that to store in the Oracle. And one additional step is crucial for most projects. The step is delay. Usually when feeds post data to store it on chain, it's immediately accessible by anyone and anyone can use it. But since we have very volatile prices of most of the assets on blockchains, it is actually not a very good idea to use this value directly, because this data about prices is actually public. So anyone can take it, put it together with a transaction that actually does something with this price, and they can use and front run the protocol or some other projects with the data they have off chain, and then they can use it together with some other functions that they can call on contracts. So, for example, if a price falls very rapidly, but this is due to some tampering with the prices on the feed side, having a delay always is a last resort, and you could stop the project for actually being rug pulled or something in time. So usually it is a good idea to have a delay implemented within the whole Oracle system to be able to counteract these malicious behaviors. And Maker implemented median and the delay in Solidity. The first is available at this address. So this is the medianizer, the contract that takes all the values provided by feeds, verifies that they were actually signed by allowed feeds, and then stores this data. And OSM means Oracle Security Module, which actually introduces this delay. So let's go into code. This is a Solidity contract for the medianizer. We can ignore the libnode class because it's just a small detail that we are not concerned about right now. But as you can see, the median contract has some authorization methods and fields which are utilized to control who can write and who can read to this contract. For example, we have words that determine who is the admin of this contract, so who can change values like parameters in it. And also we have a list of oracles so these are the feeds and their public addresses that we allow them to push the data to our medianizer contract. And then we have addresses of contracts that can read from the median contract. So as you can see here, we have a modifier that's called toll. So we require the message sender to be in the list of the buds or buddies, and if not, the transaction will be reverted. And then we have the whole update function. It's called poke. By the way, it's part of the Taiwanese language used in Maker protocol in multiple contracts, which means that, like, for example, many of the functions or most of the functions are 4-letter words. So we poke the contract to update the data. Let's quickly go through the whole function. So first, we require that the length of the array that we provide, so the list of the prices that we provide, is exactly what we determined to be the bar. So for example, in Maker, the bar is usually at 13. So out of the 26 feeds that we have, we need at least half of them to be used in an update, so we can reliably determine the price for the asset. And then we loop through the whole list of prices with signatures, and we recover the address of the signer using a recover function, which I will talk about later. And then we require the signer of the message to be in the list of oracles. And we also require that every data point that we use to update the contract is actually younger than the latest medianizer update. And then we make sure that the list is already ordered, so we can choose the middle value as the median of an uneven number of items in an array. And then we just store it. So we've got the two crucial parameter functions of Oracle here. So we verified that the data is correct and signed by allowed feeds, and then we determine the median. So this is our consensus, and we store it on chain. And now about recovering the signer address. So we've got a simple function that actually uses Ethereum's EC recover function, and it's capable, given the signature, which is divided into VRS parameters, given the signatures and the values that were signed, it's capable of determining who actually signed the list, this particular price. So then if we have this address, we can compare it with the array of with the list of addresses that are allowed to update the contract. And this part is used to introduce the 1 hour delay. We have defined some constants and some values, some fields that determine how how long ago was the medianizer updated, and then when we poke the OSM, I'm sorry. So when we poke the OSM, we updated the values into the security module. We take the current we set the current value as the next one, and then we set the next one as the value that has been provided in this update. So as you can see, we have implemented a way to make sure that we know in advance what price will the Oracle system as a whole show to the external contracts to be used for anything they actually want. And this is a small dashboard that was created by the community of Maker, and it shows the medianizer price as it is stored in the medianizer contract, and then OSM price, the current and the next OSM price. As you can see, ETH was updated 8 minutes ago here, and for example, USDT was updated 133 hours ago. That actually is because we have disabled updating USDT because we are no longer using it. So if you have any questions, I'm open to them and looking forward. And this is a QR code for this presentation, actually. Do we have any questions?
We don't have any questions at the moment.
Very well. The only thing I would like to say is that, of course, as most of the projects, we are hiring. So if you are a backend developer, mostly in Go, or a smart contracts developer, or a front-end developer, just contact me and I will forward your call to whoever is responsible for handling that on our side. So thank you. I'm looking forward to any contacts from you. You can see my Twitter handle here and my blog address. There's nothing really up to date there, but anyway. So thank you very much, and hope to see you next time.